Now that we know what an empirical formula is, let's try to work from some data and figure out what the empirical formula of a compound is. So you'll always be given the percent composition of a compound. So here we have a compound that's 38.67% carbon, 16.22% hydrogen, and 45.11% nitrogen. And there's several steps that we need to follow in order to find the empirical formula of a compound. And I'll list them first here, and then once we list them, we'll try it out on this example. So step number 1 is you are going to convert from percent to grams. Convert from percent to grams. Second, convert grams to moles. Third, divide all mole values by the smallest mole value. And then fourth, write the resulting numbers as subscripts in an empirical formula. So we have percent to grams, convert grams to moles, divide by the smallest mole value, and then write the resulting numbers as subscripts. So let's do this. How do we convert percent to grams? Well, this is the easiest step. So we will take 38.67% carbon, and to convert that to grams, well, we're going to say we have 38.67 grams of carbon. Well, why can we do this? Why can we just say, well, it's the same number, just change the percent side to grams? Well, remember, percent means out of 100. So if we assume that our total sample size is 100 grams, well, 38.67% of 100 is 38.67 grams. Just like 50% of 100 is 50, 25% of 100 is 25, 38.67% of 100 is 38.67. And we'll do the exact same thing with the other elements. So we end up with hydrogen, 16.22%. Hydrogen becomes 16.22 grams of hydrogen. And then 45.11% nitrogen becomes 45.11 grams of nitrogen. Notice how I'm always rewriting the name of the element. This is going to be very important because we have to keep track of several elements at once. So the next step is we have to convert grams to moles. We know how to do this. So 38.67 grams of carbon over 1 times new fraction, grams carbon, moles carbon. Grams carbon cancels, we're left with moles, and in the end we get, let's see, 1 mole is 12.01 grams of carbon, and we get 3.22 moles of carbon. So now we'll do this for the other two elements as well. So I've written out the hydrogen and nitrogen calculations to get moles, and now we're on to step number 3. Divide all mole values by the smallest mole value. Well, the smallest one is actually 3.22. We have that twice. And we need to divide all the numbers by that. So I'll divide 3.22 by 3.22. I'll divide 16.05 by 3.22. and I'll divide 3.22 by 3.22. And when we do this, we get 1 with carbon, we get 1 with nitrogen, and we get 4.98, which rounds to 5 with hydrogen. So now we're on to step 4, and we write the resulting numbers as subscripts. So our final answer is C1, H5, N1. And that is the empirical formula of this compound with this percent composition. Let's try one more problem, and this time I'm going to just write out all of the steps. I'm not going to talk through them, but there's going to be a difference at the end here with these numbers. So I've written out all of the calculations up through part 2, and now I have to divide by the small one. So I'm going to divide by the small value, which in this case is 2.20. And in this case I get 1. In this case I get 1.5. And in the last one I get 1.99, which will round to 2. So notice how when I said here I had 1.99 I could round, but 1.5 is too far away to round. So I need to give you some rounding rules for when you divide by the smallest value. Only round to the nearest whole number if the decimal place is 0.1 or lower, or 0.9 or higher. And if you had 0.89, that's about 0.9, so you could round that up. But if you have a decimal that's 0.5 or 0.3 or 0.6, you can't round that. So if you have 0.5, multiply all terms by 2 to get a whole number. If you have a 0.3 or 0.6, multiply by 3 to get a whole number. And why can't we just leave this as 1.5? Well, you can't have 1.5 hydrogen atoms in your compound. It just doesn't make sense. You can't split an atom and still have the same type of atom. So in this case, because we have a 1.5, we need to multiply that by 2 to get a whole number. And when we multiply it by 2, I get 3. But because I multiplied the hydrogen by 2, I also have to multiply the others by 2. So the new subscripts will be these. And our empirical formula is C2, H3, O4. The last thing I want to say about empirical formulas is I know there are a lot of steps, but you can remember this in this semi kind of rhyme. Just remember percent to grams, grams to moles, divide by small, multiply till whole. So again, percent to grams, grams to moles, divide by small, multiply till whole. Percent to grams, grams to moles, divide by small, multiply until whole.